The example in the book that runs from figure 7.4 all the way through figure 7.13 is of a public health nurse who wants to test the null hypothesis that the 6-year-old boys in her county average 48 inches in height, on the basis of the knowledge that 48 inches is the average height for normal 6-year-old boys in the United States as a whole. Let's assume that the nurse thinks that for some reason, perhaps better nutrition, perhaps better health care, that the 6-year-old boys in her county are actually taller than the average 48 inches for the entire country, but she does not want to simply make this assumption in the absence of data, so she wants to test an alternative hypothesis that 6-year-old boys in her county are actually taller than 6-year-old boys in the country as a whole. So her null hypothesis will remain that the height of 6-year-old boys in her county is 48 inches, but her alternative will be that the average height of 6-year-old boys in her county is taller than 48 inches. Further, she may decide that as her alternative hypothesis, she will say that 6-year-old boys in her county are 50 inches tall. If she says that the alternative hypothesis is that 6-year-old boys in her county are 50 inches tall, she has immediately done two things. First, she has limited the value of beta, that is type 2 error, that she must be concerned with to a single value by saying that the alternative hypothesis is 51 inches. She no longer has to deal with an infinite number of different values of beta, or of the type 2 error. The other thing she has done is she has said that the area under this curve in which she will reject her null hypothesis is no longer both ends of the curve. She can essentially eliminate this line and say that she will only reject her null hypothesis if the value she finds in her sample is greater than this line, that is to the right of this line. But now, because she has said that her alternative is 50 inches, she has said that the entire region of rejection must be on the right side of the red line. That means that all 5% of this curve, which will be the region of rejection, must be to the right of the red line. In order to make this area above the red line 5%, she has to move the red line back to about 1.7 or 1.67 standard deviations above the mean of 48. So that is what I have done with the red line. I have moved it back to include more of the blue distribution. Now about 5% of the blue distribution is to the right of the red line. Now let us look at the effect of including the distribution around a mean of 50. I've just added the distribution around a mean of 50, and as can be seen, type 2 error in this case is everything to the left of the red line, which is probably something in the neighborhood of 40 to 45% of the distribution around 50 inches. So if she goes ahead with her research and draws a sample of 100 children, knowing that the standard deviation is approximately 10. She will have a type 2 error of between 40 and 45%.